prevalent under the home. The weather is an external factor, as is the landscape that you're cultivating. The grass, the gardens. And then we have internal factors in the house as a system, which I would characterize as your conditioning equipment, your indoor plumbing, and of course one of the most important of these is the activities of daily living of the people that live in the homes. This would include both the people and the pets. So other activities that figure heavily into the quality of your indoor environment are your eating and cooking habits, your bathing, grooming, and cleaning habits, and then something that we can't avoid if we're going to be living in our homes, your breathing habits. So those are how I like to sort of generalize the indoor environment. I see in this slide we also have a plant. There has been some studies in the past that have indicated that plants can be used as filters for your indoor environment, and I certainly subscribe to that, but I don't think that they can do the whole job by any means. So we do know that there is a problem with our indoor environment because of some of these statistics that are up here on the board. And the EPA report, the EPA, the American Lung Association, the American Medical Association, for once, seem to agree that the air you breathe inside your house can cause issues, health issues. And the EPA estimates that usually 3 to 5 times as polluted as the air outside, and it can go up to 100 times. Next slide. Yes. So I think I'd like to go to the slide after this. Okay. Brian, if you could. Sure. Talk about what are some of the pollutants in the home that lead to health issues. So usually the top pollutants include formaldehyde, which is a colorless gas with somewhat of a pungent odor. But any of these odors that are associated with these pollutants are easy for the human to get used to. It takes about 3 minutes to become used to any odor, and then you have to go back outside into cleaner air to again begin to smell the effects. You find formaldehydes in furnishings, rugs, glues, drywall, carpeting, paints, some insulation, and in every case, ventilation will lower the concentration of formaldehyde in an enclosed environment. You have radon, which is a colorless, odorless gas which is found in the soil in about 15% of under American homes. It's the second leading cause of lung cancer after cigarette smoking. It seeps into the building through cracks, basement walls, and in some cases can come in through groundwater. Ventilation lowers the concentration, but if you have a depressurized house, you can also increase the amount of radon that's coming into your house. Carbon dioxide is something that you will find in every house where you have people living. It's colorless and odorless, and it's due to our respiration. And we can certainly lower the concentration of that with ventilation. VOCs, volatile organic compounds. Most are visibly undetected, but can have a detectable smell. This might be what you'd be smelling in a new car, for example. But again, all these odors are quickly vanish from our radar because we get used to them so quickly. So furnishings, pesticides, adhesives, solvents, cleaning and cooking products. And we can definitely lower the concentration unless the outside air has a greater concentration. One of the biggest pollutants in our indoor environment is water. So we have humidity in the air, and we can get condensation on cooler surfaces of walls, on walls, in walls, and on windows. And the humidity in our house is the result of household activities, washing, showering, bathing, cooking, new furnishings, and leaky basements. It's imperative that you do not let standing water accumulate in your house. And ventilation can certainly lower the relative humidity in the winter, and it can also raise it in your house in the summertime. So it's humidity is highly weather dependent and activity dependent in homes. We also have, animal dander. I was a city boy, and the largest pet that I kept was a small turtle. And of course, we found it years later under the washing machine dead. But about 20 years ago, moving to the country, I was able to learn to keep animals, dogs and cats, and I'm amazed at how much dust and dander that these animals produce. So it's something that we can affect with ventilation as well by certainly removing and removing some of the odors and dander that are generated. Mold as a pollutant once you have mold in your house, you must mitigate it. You can prevent mold with a good balanced ventilation system. So let's go to the effects. What effects do these pollutants have on your indoor air quality, and what are the effects basically on people? This is certainly a partial list of the issues that can develop as a result of poor indoor air quality. And again, these are highly individualized situations. For example, in our work, we see a lot of ventilation systems, and you can have ventilation systems in two homes side by side, which will have different levels of pollutants trapped in the filters, and it's primarily dependent on the activities of daily living of the people that are in the home. So we're going to see where some of these pollutants come from. Again, if you are landscaping and you are having herbicides put on your lawn and you're not taking your shoes off before you come into your home, you're dragging the pollutants onto your carpet where your animals and your children are playing. Not good. We talked a little bit about pets. Combustion products are particularly interesting. Obviously, you shouldn't have your furnaces are going to be tuned up so that you're not going to be generating nitrogen oxide or carbon monoxide. But if you do, ventilation will be a band-aid that will perhaps save your life in some instances. Dust, I wish I could tell you that ventilation would keep you from having to dust your house every week, but I think that would be a bit of an exaggeration. Enthalpy happens, and dust is going to be something we're going to try to manage as best we can. Another thing that has always sort of amazed me in terms of pollutants is in new homes especially. We have our houses built, and ventilation is generally the last thing that the customer is presented with after a better quality of cabinetry and granite countertops. And we have our newly painted walls, our concrete that's not yet fully dry, our wood, and our new furniture, and then the first winter we heat it up. And that heat is going to be driving all of these volatile organic compounds and formaldehyde right into the air. And one of the first things we should be thinking about is how to ventilate our houses properly. So these are some of the causes and effects. I had a couple of comments on some of these, as well as being able to accommodate pets in my country incarnation. I was also able to use a wood stove, and I will guarantee you that wood stoves definitely have fine particulates associated with them.
So is that to be careful with wood stoves, or?
Well, I mean, yeah, I mean, you need to have a ventilation strategy with a wood stove. And the tighter the home gets, you might also have to have an air combustion strategy for wood stoves. Absolutely.
Which of these maybe is the most, I don't want to say deadly, but what has maybe the biggest impact on health? Is there one that sticks out that, is they kind of like the majority, or is there one that's kind of worse than the other to make sure or does it all kind of come?
Well, yeah, I mean, that's another thing about the effects of these pollutants, and it's highly individualized, and the effects are also cumulative. And the other thing about the cumulative effects of VOCs and formaldehydes and tobacco smoke and all of these things is that once you pass the threshold, it's very difficult or not impossible to go back. So, when people will come up with different, they will get sick at different times, and once people have actually enter into the land of chemical sensitivities, it's very difficult to go back. Then it becomes more important than ever that you take some of the steps that we're going to be talking about in terms of mitigating these pollutants. So does anybody out there have any comments or or individual experiences that you want to share with us at this time?
Yeah, you can ask a question or raise your hand. There's a couple of features that will let us know if you want to join the conversation. We did get a question and we covered it. So I sent out the PowerPoint slides in the chat, and hopefully you guys all have that. Nothing at this point. So our next slide has a video, and it's a pretty high-level video, but it's kind of one of those 50,000 foot view of indoor air pollution. Really, what I took away from it was kind of most people think of air pollution and air quality outdoors, and really what we're stressing is the indoor air quality as the problem. So there's a link in the PowerPoint slides, and we found that the videos kind of come over choppy, but this is a fun little 4 or 5 minute video that in your spare time we recommend checking out. You want to say anything about this video? Those are high level.
Yeah, I think that's something that folks can watch. It's showing that the issue is actually seeping into the mainstream media.
Yeah, which is great. This was awesome on ABC. So that was with Dan Shapley with the Daily Green, and we visit the Daily Green often. We like to engage in those discussions. So you'll see us out on the web. So check out the Daily Green and the ABC News video here when you get a chance. We did a formaldehyde experiment. We did this last summer, and we were using green cleaners, and we found that formaldehyde ratings really shot out the roof, and it really just demonstrated, even green cleaners today, marketed as green, have some bad chemicals in there that can impact your indoor air quality. And if you click on this link, it'll take you out there, and we're getting more and more green cleaners, good content to put on our YouTube page. So please check that out. It's at youtube.com/RecoupAerator, and you'll be able to see testimonials. We put our formaldehyde experiment. And this is actually our second webinar. We did one a few months ago with Jason Morosco on really technical details. We put all those technical training videos out there too. So please be familiar with our YouTube page, and we'll post out this health webinar out there too as a recording.
So these are some facts that were collected about indoor environments and the effects that they have on people. Radon seems to really be a pretty well studied phenomena, and it's pretty widespread. And since we're going to be talking about our balanced ventilation product coming up here as a solution to poor indoor air quality, I should mention that we had a project with the Wright-Patterson Air Force Base a number of years ago, where we mitigated 62 base housing units of varying sizes, and we were able to mitigate radon down to the acceptable 4 picocuries per liter in all of those units, and some of the radon levels were as high as 18 picocuries per liter. So we do have generally ventilation is recommended for homes with radon levels below 16. But the more common and more cost-effective way to mitigate radon is through sub-slab radon mitigation systems. They're less expensive than our system would be, but in some instances they can't be used because of the substrate under the foundations, and sometimes the foundation walls are built of old sandstone blocks, for example. So radon mitigators will use our system in some situations. Now, we have a test going on right now with a professor at Denison University, and he's trying to correlate radon reduction and indoor air quality with pressurization. So if you keep a slight positive pressure on the house, he's hoping that it will not only be able to mitigate the radon, but be able to use the other benefits of our system, namely dilution and bringing in fresh air to improve his overall indoor air quality. So we'll keep you posted on the results of that as they come in. Next slide. Next slide. So here are the fixes. And the first fix is source control. So it's just like, the best way to avoid pregnancy is abstinence. The best way to avoid indoor air pollution is not bring any products that have any outgassing potential or detrimental potential into your house. So no carpets, no sofas, no cleaning products, no living inside of your house. So this is an important piece of the puzzle, and it's your first line of defense. But don't store gasoline in your attached garage. Don't start your car inside of your garage. I mean, all of these things are not all of these things are practical. So each of us is going to have issues in our home, even if we just breathe in it, much less cook or have pets or use glass cleaners or use any of these products. So what I feel about source control is, yes, definitely, it's like you eat the best food you can find, the freshest food, the most nutritious food, maybe the organic food that you can find. And source control is tremendously important. But even by paying attention to source control, you're still going to have a need for ventilation. And ventilation is your second line of defense. People often say that people often think that air filtration is what you should do after source control. But again, the EPA and the American Lung Association, the American Medical Association all agree that ventilation is what should happen before filtration. So ventilation comes in a number of guises, and those guises include exhaust-only ventilation. An example of that would be your range hood, which is removing cooking odors right over your stove. Bathroom ventilation, which is removing moisture directly from the source. You have supply-only ventilation, which is ventilation which is characterized by basically a hole in the wall, generally connected to your furnace. And that will supply some fresh air ventilation in your home. And at least with a make-up air unit where your fresh air is coming from. And then what we propose and the product we make implements is balanced ventilation, which brings in fresh air from the outside at the same time removing the stale air in the house along with the pollutants. And then the final filtration, you want to filter the incoming air that you're using for a healthier indoor environment. You have furnace filters, so the air that you're circulating in your house is getting cleaner. You also would want to have a filter on your incoming outdoor air stream. It's going to trap pollens and mold spores. And go ahead, Ryan. Next slide. This is more to the point of source control, doing maintenance on your equipment, tightening up your house. We all think that we all are interested in saving energy, and we also know that saving energy involves taking care of the indoor environment. And to take care of the indoor environment, you're going to need ventilation. So filtration, I mean, you always pay an energy penalty for filtration. The thicker the more effective the filter you put on your furnace, the more energy it's going to cost to pull the air across it. Filtration is measured in MERV ratings, which I wish that would trip off my tongue. It's a standard rating system. A HEPA filter, which is the most well known, is a MERV 18. The product that we sell, the RecoupAerator, has a MERV 12 rating, which will take care of pollens and mold spores. If you open your window, you're going to get opening your window is actually a ventilation strategy that I subscribe to, if you can do it. It costs the least amount of money in the seasons when you're not heating and cooling, of course. So what we're trying to do here is balance, getting the fresh air in with the energy that we've already paid for in the house. Some people can't open their windows, either because they're allergic to the pollens and mold spores that's outside, or they have security issues. So we're talking about now we're talking about a balanced approach that balances your need for indoor ventilation and filtration and energy use. So you want to get the best ventilation you can in terms of filtration at the lowest possible cost. And that's where heat and energy recovery ventilators are something that you want to consider. There are homes that are being built now that are super tight homes. We have Energy Star homes. We have passive homes, which are being built to a very high standard, which actually demand a high-performance balanced ventilation system. They are attempting to address climate change and our carbon footprint by reducing the energy that's used in the house by 85 to 90%. And this is the only way that some experts feel we're going to be able to get to a position where we're not endangering our environment. And ours is one of the few units, the RecoupAerator, the UltimateAir RecoupAerator, is one of the few units made in the world that meets the standard for energy and filtration that the passive house codes require. So these are some of the components that our energy recovery ventilator will provide for you. We have a system which balances the incoming and outgoing airstream so that you don't pressurize or depressurize your house. We have a filtration system which is MERV 12. and we attempt, we help the home maintain a comfortable humidity level. We exclude a high percentage of humidity in the summertime, and we return a good portion, a comfortable portion of humidity in the winter. So we don't, control is too strong a word. We don't control ventilation because of our humidity, because it's highly dependent on the inside and outside weather conditions. Weather conditions on the outside and activity conditions on the inside.
And then here we have a couple links to a couple customer testimonials. Gilly talks about the cooking odors a lot and how she's had so many pets and grandkids coming in, and she can really tell the difference between before and after. And it's great to see how kind of passionate she is about this product. And Dave, he has a couple apartments, a couple houses he rents out, and he is another customer that sees the impact of the RecoupAerator. So check those out on our YouTube channel when you guys get a chance. And we have more customer testimonials. Did you want to highlight any of these?
Well, I mean, I think it's actually pretty amazing that the medical community is talking about ventilation. It's certainly a preventative health. It's preventative health, and it's something that our system should be more aware of. Every industrialized country in the world has ventilation standards and codes for ventilation. Many of them actually require balanced ventilation, and they've made the connection between a good indoor air quality and the cost of their healthcare system. So it's very encouraging to see the medical community touching on these issues.
Where are those laws or?
Well, codes.
Codes.
Canada has codes. Northern Europe, Central Europe, Korea, Japan. Now, some states, Oregon especially, has been encouraging to us, and by offering a rebate to people who put our product in their homes. They offer a state tax credit, $425 tax credit for installing a RecoupAerator. The most efficient and the next highest rebate is $350.
Have there been rebates that were put out for previously and now they're not still valid?
No, these are still in place. The last time I checked a couple of weeks ago. So that there are states. We finally, after 20 years, about 5 years ago, ASHRAE came out with residential ventilation recommendations, and those recommendations are for a very low continuous ventilation rate. A home of about 2,500 square feet with 5 bedrooms would require about 60 cubic feet of continuous ventilation a minute, 60 CFM. So it would change the air in your house every hour and a half or 2 hours, basically. And if those are the recommendations of that have taken them 20 years to make, to try to codify, we're hoping that other states or federal programs are going to adopt these. And we see some movement in that direction, but basically Americans don't like to be told what to do. So, these are. This slide addresses a feature of our unit. We're using high efficiency programmable motors in the system called electrically commutated motors, EC motors. And they, once they're programmed with an algorithm, they will provide through a quite extensive pressure drop, which comes about by differing lengths of duct, and we will provide the ventilation rate that the customer is calling for, even as the filters are plated. So we'll maintain a balanced ventilation, and we'll be delivering the ventilation that you require for a healthy. These are some of the other features that we have. We've talked about most of them. One of the things that I should mention is this carbon dioxide sensing option. We can run your house at a carbon dioxide is really an indicator of it's an indicator of indoor air quality. Nobody that we know has ever died of carbon dioxide poisoning, but you do get very sleepy. One of the reasons that schools started ventilating is they noticed that their students are falling asleep. If you have a conference room where folks are always falling asleep, maybe you should get some better ventilation. But what we can do is, once the level of carbon dioxide is exceeded in a room or in the house as a result of greater activity or more people, we can boost the airflow of the ventilation system and reduce it rather rapidly. Another feature that I think is interesting is the Economizer feature. We call it EconoCool. When the evenings are cooler than the days, you can stop the heat exchange in our unit, exhaust the warmer indoor air, and bring in cooler night air between 55 and 70 degree outside air. So it acts in the same way as the old attic fan used to act. You would open the windows on the ground floor, turn on this enormous attic fan, and flush your house with cool air. We can do that automatically for you.
Can you take a question, Craig?
I hope so.
We have 5 more minutes. We'll wrap this up. But Brian asked, that is a scary comment about the ECM motors, because this is what we should not be saying. These motors can overcome bad ducts. Bad ducts are bad ducts. Does that make sense?
Yeah. I mean, yeah. What he's saying is we should do proper duct design when installing our units. We can overcome static pressure in ducts with our unit. The main point is we're going to be delivering the air. Bad duct design is bad duct design. We're going to be using more energy to overcome that. But it's oftentimes impossible to get the same length of duct on both sides of the unit. So I totally agree with this comment. Absolutely.
And would this video talk about the duct? I know we have some.
Yeah, I'm not sure if this. One of Jason's technical. It's going to answer this one.
But we do have some really great information out there that Jason provides. So we have addressed duct design. I remember recording some of it. But good question, good answer, Craig. Was there anything else on this table that you wanted to call out?
I mean, the balanced and unbalanced capabilities of our unit are sometimes helpful to people. We definitely want to be sure that the home is not depressurized, both for the sake of radon entering the house, and in some cases bringing humidity into it. So, the pressure capabilities are important. We have a rather sophisticated accessory that every 10 minutes takes the pressure reading outside and inside the house and compensates the inside and outside airflow to compensate for it. And we do have jumpers on the unit that can bring in 20, 40, or 60 more CFM that is being exhausted by moving a jumper. Those are useful in some situations. We also understand that all of God's critters need maintenance. We always encourage people to install our product in a way that can be maintained as easily as possible. We're going to have to think about maintenance at least once a year.
Yeah, we have a good video on that too.
These are all important issues.
We have another question from Gerald asking, how do you size the unit for various size houses?
That goes along with the ASHRAE 62.2 recommendations. They like to have 0.01 CFM per square foot. So if you had a 2,000 square foot home, you would want 20 CFM plus 7.5 CFM per bedroom, plus one bedroom. So if you had 4 bedrooms in the house, they would want, let's say 3 bedrooms, you would want 7.5 times 4, which is somewhere around 30. You add 30 to the 20 CFM for the square footage, you get 50. They would want 50 CFM of continuous ventilation in the home.
So what about maybe like a 3,000 square foot house? What's kind of like, maybe if you have one unit, what's the highest square
well,
foot?
Well, in terms of
is there any general?
Yeah, you can go up to a 6,000 square foot home with a unit that delivers 200 CFM. But generally, it's a question of how you circulate that air. Usually, a 6,000 square foot house is going to have 2 air handling systems. If you're not doing your home, separate ducting system.
Okay.
And if you have any more questions on that, I can answer more specifically by, give me a call at the 800 number, and we can talk about your individual.
What number is this 740? Is that your desk? Is that the office?
Yeah, that's my cell phone, but that's hardly ever on.
Okay.
Call that 800 number.
Right. And, if you've talked to us already and are looking for a quote or looking for an installer, Greg Winneck is the person to contact, and his information is listed there. An email or phone are good options for Greg. Well, great. That was fun. That was 45 minutes. That went by pretty quick. So we're planning on doing these again. So we would really love feedback, and shoot us back feedback any way you can. You have Greg and Craig's email right there and phone numbers. You're going to get a follow-up email from us with a link to the recorded webinar, and you can reply to that, and we would love to hear back from you. Again, thanks so much for your time, and we hope to talk to you again.